Okay, last section we dealt with special products by looking at the difference of squares. Now we are going to review perfect squares. So with this, number 1 says we're supposed to multiply these following binomials. It says the quantity x plus 6 squared. Now if you remember with that square, that told us that we had that special formula where our answer is going to be the first term squared plus twice the first term and the second term plus the second term squared. Okay, and if you remember, I said that you could just distribute this out, but knowing this formula would help later. Well, this is later. Okay, so first term is x, second term is 6. So then our final answer, simplified, would be x squared plus 12x plus 36. Okay, same thing on 2. Again, setting up the formula correctly. And remember that that middle term is always twice the two terms together because we are adding two of the exact same terms together, which really means we are multiplying by 2. So first term is x, second term is 8. Final answer, x squared plus 16x plus 64. So again, that outside number is always going to be our constant term squared. The middle number is going to be our constant term, doubled the constant term. Okay, so one more of these. X squared, we're adding twice. This is going to be a little bit different because we have a negative in there. And we'll see how that negative comes into play in just a second here. Okay, so we do still have our x, but now we happen to have a negative 9. Well, looking at this, we have x squared. 2 times x times negative 9 is a negative 18x. Negative 9 squared is a positive 81. So if you remember, if we did have a negative in the middle, our middle term was negative, but our outside term was always positive. Okay, so now what we're going to do, again, is we're going to hit the rewind button on this. We're going to undo all of these in order to get that trinomial back to a perfect square. And the two things that we just found out, we found out that the outside number is always the square root of the number we're putting in our parenthesis. And to double check that, this number right here always has to be twice the square root of that number. So when we look at a trinomial to see if it's a perfect square, we go ahead and test. What is the square root of 64? Square root of 64 is 8. What is 8 times 2? 8 times 2 is 16. Okay, so you square root, you double, and if those two numbers coincide, then we're good to go. Then it's this number that we are going to use right up here in our binomial. So let's go ahead and do that. I have a 25. I'm going to test this. What is the square root of 25? Here. Square root of 25 is 5. What is 5 times 2? 5 times 2 is 10. So is this a perfect square? Yes, it is. So the way that we are going to write this, again, here's the number that we're focusing on. This is going to be the quantity of x plus 5 squared, because 5 squared is 25, and then 5 doubled is 10. Again, keep in mind that we're undoing everything up here. We're undoing the formula that we used to multiply this out. So first step, I want to see that this is a perfect square. It is. Okay, so going through my test, the square root of 49 is 7. Is 7 times 2 14? Yes, it is. So that number that I'm looking for is 7, which means that I'm going to write this as x because it's going to be the square root of the first term plus the square root of the last term squared. Okay, so didn't really talk about that over here, but if it does pass this little test right here, again, first term is going to be x, second term is going to be the square root or that of that, or half of that. Notice it's the same number. All right, last one. I notice that I do have a perfect square, so I'm going to go ahead and test this. Square root of 64 is 8. 8 times 2 is 16. So that does work. The only difference is that subtraction sign. So if our middle term has a subtraction sign in there, I know it's going to be, if our middle term is negative, I know that we're going to have a negative here. So 8 is the number I'm using. Okay, this is a difference of perfect squares because that middle term is negative. Okay, so undoing the operation. Now we're going to go one step further and say what should the constant be in the following polynomials in order for the expression to be a perfect square trinomial. Okay, so now we have to look at what we did up here and kind of work a little bit even more forward. So we're supposed to put a number in here to make this all a perfect square. Well, look at what we did right here. We took whatever that perfect square was and we multiplied it by 2. So now we're going to have to undo that. What are we going to do to that 6? It looks like we're going to take that 6 and we're going to divide it by 2 because we have to undo that multiplication. So we're going to divide by 2 in order to get this number over here in the square. Then what did we do? We took the square root of that number in order to find out what went here. Well, we want to undo that, so we're going to take the square. So what number should be in there? 6 divided by 2 is 3. 3 squared is 9. So does that work? X squared plus 6x plus 9. Is that a perfect square? It is, because if we tested this, square root of 9 is 3. 3 times 2 is 6. Okay, so that then would be our perfect square trinomial. Okay, same thing here. Again, what we do is we take the coefficient of that middle term. We have to chop them in half, and then we have to square it. So 4 divided by 2 is 2. 2 squared is 4. So this is kind of a different one because our middle term and our outside term are the same. And that's because that magic number that we're going to use would be 2. So if we were to simplify this down, what's the square root of 4? 2. What's 2 times 2? 4. So 2 would be the number inside our parenthesis. Here, 3 would be our number inside a parenthesis. Notice that number shows up right here. Okay, 6 divided by 2 is going to be what's inside a parenthesis. 4 divided by 2 is what's going to be with our binomial. Okay, one more. Let's try this. We now have a negative 8, and we're dividing that by 2, and we're squaring it. Well, negative 8 divided by 2 is negative 4. Remember, any negative number squared is positive. So a positive 16 would go right here. X squared minus 8x plus 16 would give us a perfect square trinomial. What would this look like, though, if we did factor it? Negative 8 divided by 2 is a negative 4. So this would be x minus 4 squared. Okay, so we are still factoring. And notice the reason why we're factoring. Again, with this one, we can't solve something that looks like this with the square on the x. But look at what we did with the square here. We bumped it off of the x over here over the quantity. So look what happens. If I did happen to set this equal to 0, and I was trying to figure out what to put in for x, I would have to undo PEMDAS, parentheses, and exponents. So I would have to get rid of that exponent. Well, how do you undo something squared? You take the square root. Notice what that does. Because This parenthesis is guarding these two. All that does is it picks off that square. Okay, so I have x minus 4. Square root of 0 is 0. I'm going to add a 4 over, so x equals 4. This is one of those 5% of the times that we're only going to get one solution for these quadratic equations. Okay, so showing you that last quick step so you understand why we would even want to do what we're going to do in this next section. Okay, go ahead and get out the notes and vocab for this section. Okay, objective of this section is to solve quadratic equations, which is what we've been doing the last quite a few sections, but now we're completing the square. This first part goes over what we had talked about in that first section on how to look at multiplying out a perfect square, but then also factoring it back down. What we're doing, adding on that coefficient, is called completing the square. Again, we want to complete a square so we can factor out that square. That way the square is not on the variable, it's actually on that binomial. Okay, they say b divided by 2, and we talked about that the number, the coefficient we're going to use in our binomial is just half that middle term. So they tell us the steps, which is what we did. So I'm going to go ahead and leave their steps because they're pretty good. Find half of b, square it, and then add it to your a squared plus bx. Okay, we already did example 1 in our intro. So again, just to review, we're going to take half of 4 and we're going to square it. So we know 2 squared equals 4. So that's what we would put in here for C. Okay, we want to create a perfect square. So what we just did was we completed the square. That way, if we did have to factor this, it would be 4 divided by 2. Our constant would be a positive 2 squared. Okay, our whole goal is to get that exponent of 2 off of the x, so we can go ahead and just solve for a single x. Okay, with everything we did in the introduction, I think you should be ready to try guided practice 1. Okay, chopping -8 in half and squaring it, we should get a positive 16. It doesn't tell you to keep going with writing this as 2 perfect square binomials, but I do just so we understand the relationship here. Some students make the mistake of putting a -8 in here, but remember these two numbers are related to this because -4 squared shows up right here and double -4 shows up right here. Okay, so with that in mind, we're going to go ahead and use this completing the square to solve an equation. So before we do anything, I'm going to look at this positive 12 out here. It's not a perfect square, so it's basically in the way. So it says first we have to isolate that x squared and our -6x, so we can go ahead and put in a perfect square number right here. So how do I isolate him? I subtract him from both sides. So that way I have kind of a fresh start. I have x squared minus 6x. I do keep a big space right here because I know that I'm going to complete the square with some number, and I'm going to put that 7 over here. So what is that some number? Well, I'm going to find that out. -6 divided by 2 squared, -3 squared is 9. So if I put a 9 right here, I'm going to have a perfect square that I can work with. So I'm going to add a 9. But remember now I have an equal sign, so whatever I do to one side of the equation, I have to do to the other. Okay, so there I go. I have my perfect square. Well, what am I supposed to do with it? I'm supposed to go ahead and factor this now. So the number that I'm going to use for my binomial is right there. I'm going to rewrite this as x minus 3 squared. I didn't change its value at all. That is the factored form of x squared minus 6x plus 9 equals 16. Okay, why would I do that? Because now look at this. My goal was to get that exponent of 2 off of the x, and I did it. So I can go ahead and solve for x. I'm going to undo PEMDAS. So first thing I have to do is get rid of that square. We found out in the intro, that means I'm going to take the square root of both sides. So again, understanding the square root of a quantity squared is just going to lift off that square. I'm left with x minus 3 equals 4, right? Well, I want to go back to what we had talked about earlier with x squared equals 16. We had decided that x could equal 4 here, but what else could it equal? Negative 4 times negative 4 gives us a positive 16. So it could also equal negative 4. So when we square root both sides, sure, we have an answer of x minus 3 equals 4, but we also have an answer of x minus 3 equals a negative 4. We have to keep that in mind, that again, there's our two answers. So we're going to go ahead and add 3. We know that x could equal 7. Add 3. X could equal negative 1. So two mistakes commonly that I see students make right here is they forget this second equation. They forget to set it equal to the negative of the square root here. Another mistake that I see, they set them equal, but they say, oh, well, if x equals 7 up here, then the opposite of that is a negative 7. That's not true, because again, it's the negative 4, we are adding a 3 to it. So two mistakes that we need to slow down and make sure that we do not make. Okay, so step 1, isolate the x squared and the b squared. Step 2, figure out what number to put in there in order to complete the square, make a perfect square. Step 3, factor it into two perfect square binomials, and then go ahead and solve the equation by square rooting both sides, setting it equal to both the positive and the negative, and then solving from there. Okay, try guided practice 2. Okay, of course, a little bit different because again, we isolated the 3. We ended up with a 5 over here. Figured out what to put in here by chopping the negative 12 in half and then squaring that, which was a 36. Added 36 to one side, have to add it to the other. So now that we have our perfect square trinomial, we can factor that down into two binomials of x minus 6, because remember, if that middle term is negative, then in our parentheses we are going to have a negative, equals 41. 41 isn't a perfect square, so we are going to have to use just a decimal form of it. So we have x minus 6 equals 6.4. X minus 6 equals a negative 6.4. So our two answers, 12 and 4/10 and negative 4/10. Okay, a lot of different steps we have to make sure that we go through. And of course, here's another step. So in order for all of this to happen, our x squared value has to be 1. Our coefficient, our leading coefficient has to be 1. So when we have a leading coefficient that is not 1, we have to divide everything by that leading coefficient in order to get what we need. So with this negative 2, he is in our way. We have to divide him out, which means that we have a negative 2 divided by negative 2, which is our x squared, which is what we wanted. 8 divided by negative 2 is negative 4x. Negative 18 divided by negative 2, positive 9. Negative 9. No, positive 9. And then that equals 0. Because 0 divided by negative 2 is 0. I didn't forget it. It just didn't affect it. Okay? So step 1, divided out the leading coefficient in order to get a leading coefficient of 2. Step 2, isolate my x squared and my negative 4x by subtracting this 9 over. Okay, actually, good point here. 9 is a perfect square, but let's go through quickly all of our little steps, where square root of 9 is 3, 3 times 2 is 6. So this isn't a perfect square binomial, which means we have to get rid of them. Okay, so we end up with x squared minus 4x. We're going to create a masterpiece right there, so we're going to set that aside and put a negative 9 over here. Then we have to figure out what we are going to put there. We're going to chop negative 4 in half, and we're going to square it. So what is negative 2 squared? Negative 2 squared is a positive 4. Okay, just a second. I've got to, that at least semi-color code this so we can see what we're doing. Positive 4, which means we have to add a 4 to the other side. Okay, next up. Again, some students get kind of stuck right here because there's a lot of different steps that we're dealing with. Now what? We put that fancy number in there. Why did we do that? Because again, now we can factor this down to two perfect square binomials where we're going to have x minus 2 squared. And that is going to be set equal to a negative 9 plus 4, which is a negative 5. Okay, now next step, we are going to solve this equation for x. Undoing PEMDAS, we have a square root sign here. So we're going to take the square root of both sides. And we're going to figure out what the square root of negative 5 is by grabbing our calculator. And our calculator is going to say error. So I'm going to write x minus 2 and it's going to say error. Why? Because we have a negative here. You can't take a square root of a negative number. So what does that mean? That means no solution. If you have this set up, when you go to solve it and there is a negative that it's set equal to, we know it's a no solution because you cannot take a square root of a negative number. Okay, keep that in mind. Don't stop right here. I know that there was a negative 9 over here, but sometimes we're adding something to it that will turn it into positive. Here, our number just wasn't big enough. Okay, so do keep this step in mind. Okay, you're on to guided practice 3. Go ahead and give it a try. Okay, here it is with all of the many different steps on order to solve by completing the square. Divide that leading coefficient if it is not already 1, which we had to. Get your x squared and bx values alone by adding that space. Then divide that middle term in half and square it. Add that to each side. Rewrite the equation as the square of those binomials. And then solve by taking the square root of each side. Adding and subtracting to both, and remember the positive and the negative value of that right side of the equation. So 95% of the time you should get 2 different answers. All right, one more problem. Let's do this. Real world example. It says the senior class at Bay High School buys jerseys to wear to the football games. The cost of the jerseys can be modeled by this equation. Again, businesses put together these type of equations based off of many different types of factors. Okay, C is the amount it costs to buy X amount of jerseys. So, question, how many jerseys can they purchase for $430? That's our C. They told us our cost is 430 bucks. So we know that we have 1/10 x squared plus 2 4/10 x plus 25 equals 430. Okay, we're going to go through all of our steps. So step 1, divide by leading coefficient. If it's not 1, it's not 1. So we're going to have to get rid of a 1/10 on everything in order for this to work. So we're left with x squared plus 2.4 divided by 0.1, 24. That makes sense. Plus 250 equals 4,300. Okay. So step 1 is done. Step 2 says we're supposed to get our 2 values alone by subtracting this 250 over. So we end up with x squared plus 24x equals 4,050. Okay, step 3, divide middle term in half. So we are going to take 24, we're going to divide it in half, and we're going to square it. So we end up with 12 squared, which is 144. So again, adding that to both sides. Why do we do that? Because we are completing a square. We are creating a perfect square. So next step then, since we created a perfect square, we might as well rewrite it as that. Remember, this is the number we're looking for. So we're going to say x plus 12 squared equals 4050 plus that 144. So 4194. Okay, last step, solve equation. which means that, again, the whole purpose of all of this was to get that square off of the x. We do still have to square root both sides. So we end up with x plus 12 equals the square root of our 4194, which is about 6476. Remembering that I'm supposed to set that equal to both positive and negative. Technically, we didn't have to do this last one, and I will show you why in just a minute. Let's go ahead and subtract that 12 over. So we know here x could equal 5276, negative 6476, subtract 12 is the negative 7676. So question, why didn't I have to do this last one? Because I know I'm talking about how many jerseys can they purchase. I can't purchase a negative amount of jerseys. So this doesn't work. I also can't purchase 76/100ths of a jersey either. Okay, so this rounds up to 53. Is that what we can do? No, because that would cost over $430. So we will have a little bit of money left, but we can't include that 76. We are going to have to say they can purchase 52 jerseys. Again, once you get that answer, please go back to the problem and make sure we understand what we're doing. Can we round? If we do we round up? Do we round down? And why? Okay, so just followed all of our same steps, but this time solving it for a real world situation. Okay, go ahead and try guided practice 4. Okay, going through all of our crazy steps, getting down to solving. Notice how I didn't even solve half of the equation because I knew it would be negative. I got down to 66.1. And then I started debating, well, someone's going to be able to chip in a couple dollars to get that extra tiny little bit of that 66. So I'm going to say they can purchase 65 or 66 jerseys, depending on how nice their coach is, to chip in that extra little bit of money. Okay, completing the square. This is what, concept 4 that we've learned on how to solve quadratic equations. Get through this assignment and I will show you 2 very handy type of no-fail ways to solve quadratic equations next section. Okay, so go ahead and work on the assignment for this section.